Hello everyone! In today's video we're going to tackle a popular coding problem, the two-sum problem. Given an array of integers and a target value, our goal is to find the indices of two numbers in the array that add up to the target. This problem is commonly asked in coding interviews, so let's dive into two different solutions with varying time complexities. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Solution 1. O of n squared time complexity. Brute force approach. Let's start with the brute force approach, which is straightforward but not the most efficient. Here we iterate through every possible pair of numbers in the array, and check if their sum equals the target. For example, with the array 2, 7, 11, 15 and a target of 9, we would add 2 and 7, find that their sum equals 9, and then return their indices 0, 1. The time complexity for this solution is O of n squared because we're using nested loops to examine each pair. This approach works, but as the array grows larger, it becomes less efficient. Solution 2. O of n time complexity. Optimized approach. Now let's move on to a more optimized solution that reduces the time complexity to O of n by using a dictionary. Here's how it works. As we iterate through the array, we store each number's index in a dictionary. For each number, we calculate its complement by subtracting the number from the target. If this complement is already in the dictionary, it means we've found our pair. We can then return the indices of the current number and its complement. This method ensures that we only pass through the array once, making it much more efficient. Example walkthrough using the optimized approach. Let's break down how the optimized solution works with an example. Imagine we have an array nums equals 2, 7, 11, 15 and a target value of 9. Our goal is to find two numbers in the array that add up to 9 and return their indices. We start by initializing an empty dictionary called number-to-index. This dictionary will help us keep track of the numbers we've seen so far and their corresponding indices. Step 1. We begin by iterating through the array. The first number is 2, which is at index 0. We calculate the complement, which is the difference between the target and the current number. In this case, the complement is 9 minus 2 is equal to 7. Next, we check if the complement 7 is already in our dictionary. Since the dictionary is currently empty, it isn't there. We then store the current number 2 and its index 0 in the dictionary. Now, number to index looks like this. Step 2. Moving on to the next number 7, which is at index 1. Again, we calculate the complement. 9 minus 7 is equal to 2. This time, when we check our dictionary, we find that 2 is already there. This means we've found the two numbers that add up to 9. We return the indices of 2 and 7, which are 0, 1. Final output. The function returns 0, 1 as the result. This approach efficiently finds the solution in just one pass through the array, making it much faster than the brute force method. By using a dictionary, we reduce the time complexity to O of n, which is ideal for handling larger datasets. In terms of space complexity, both solutions have their trade-offs. The brute force approach doesn't require extra space, but it suffers from poor time complexity. On the other hand, the optimized solution uses extra space for the dictionary, but it significantly reduces the time required to find the solution. Overall, the optimized approach is preferable, especially for larger datasets. I hope this helps you understand the problem and how to approach it in different ways. Thanks for watching, and if you found this video helpful, don't forget to like, share and subscribe for more coding tips.